Firstly, I will introduce to you what is sequence control instruction. Sequence control instructions are executed sequentially one by one. The sequence control instruction direct the computer to process this instruction one after another in order listed in the program. All action will be executed, none will be skipped. Also, action can be input, processed, or output. Next, I will show you how to build a coding using a sequence control instruction. Before that, let's use one example question to show you clearly how to answer question about this control instruction. The problem statement shows that we have to write a problem analysis to calculate the area of a rectangle. So firstly, step 1, we have to do is analyze the problem. So from the question, we know the thing that we have to search is area rectangle. So we can categorize it as output. Next, after we find our output, we have to analyze it as we know the formula to calculate area of the rectangle is width multiplied by length. So these two can be categorized for input. Then for the last, we could easily create the process as we know the output will write after calculate and input will write after based on. So in this question, we can write our process as calculate area rectangle based on width and length. After that, for step 2, we have to know how to plan the algorithm as we know control instruction has 2 algorithms that we can write as. First one in pseudocode and next one in flowchart. I will explain to you 2 of these. For the pseudocode, we have to start with start or begin. Then put our input which is a read, width and length. Next line, we have to write the formula of area rectangle which is width multiplied with length. Then for output, write print out area rectangle. And for the last line, which is the end of the program, we have to write the stop or end. If you want to use flowchart, the IPO is still same as in the pseudocode, but you have to write draw settable shape in every IPO you have. We can start with start in capsule shape, for input in parallelogram shape, and the word process in rectangle shape. Same with input, we put our output in parallelogram shape, and for the last, put output in capsule shape. After finish all of this, we can easily create of coding by code algorithm into a Java program. Java program using a sequence structure consists a series of Java statements that will be executed sequentially from start to the end of the program. It will not involve any selection or repetition statements such as if else, if as if, while or for. In this Java program also there are some important things that we have to write in. First, set the comment. Second, import statement. Third, have class declaration, and for the last method make. Then we can proceed to write coding. The thing I want to highlight in this coding is how to declare the input, formula, and output. For our input, width and length, we can declare it by identified data type. So for this input, we can declare as double. Next, we have to know how to write formula in Java code. In Java program, we cannot use math expression to write multiple, as Java program only accepts arithmetic expression to write the coding. So you have to remember arithmetic expression for addition, subtraction, multiply, and division to code it. And for the last, declare output in system.out.print. As we use area, so we can write it as system.out.print area rectangle plus area. If you know how to declare all of this, then you can easily write the correct coding statement without any error. That's all from me. Thank you.
What is selection control structure? It is a Java program that uses a selection structure that will execute certain statement based on a certain condition. So there are 3 structures of selection based on the requirements of the problem. Single selection, dual selection, multiple selection. Then we look at the selection statements. Selection structure can be represented using 3 Java statements. First, single selection if. Second, dual selection if else. Third, multiple selection if else if. General format using if statement is first if condition and then statements. For if else statements, their general format is if condition and then statement 1 and put an else then statement 2, the last one, and if. Last but not least, for if else if statements, first if condition 1, then statement 1, then else if condition 2, and statement 2, and then else and statement 3, the last one, and if. So we go to the example for if statements. Example 1, create a program statement that will accept students' mark. If the mark is greater than 40, print the message pass. So the input is mark, process is determine message based on mark, and then output is pass. The pseudocode is begin, input mark, if mark more than 40, print pass, then end. Then, for example, using if else statement, if a student's mark is 40 or above, print the message pass, or else print the message fail. So their I input is mark, P process is determine message based on mark, output pass or fail. So the pseudocode is start, input mark, if mark more than or equal to 40, print pass, else print fail, and if stop. So we go to the if else if statement. Create a program to accept a number from user and to determine whether the number is positive, negative, or 0. Input number. Process determine message based on number. Output positive or negative or 0. And then the pseudocode begin, input number, if number more than 0, print positive. As if number less than 0, print negative. Else print 0, and if and.
Now, it is my turn to talk about repetition control structure. Let me begin. Repetition control structure is a Java program using repetition structure that will execute certain statement repeatedly as long as certain condition is true. There are 2 types of repetition control structure, which are counter control, which we can repeat the data by 10 times, and sentinel control, which we can end the data by entering -1, 999, and also 0. There are 2 statements represent repetition structure. As for counter control, we can use while and for statement, and sentinel control, we can use while statement. About while statement. While statement checks the condition before entering the loop. If condition is true, loop body will be executed. If condition is false, loop will stop. That is an example of flowchart for while statement. Now, let's move on to for statement. For statement combine all the 3 parts of looping structure in one statement. For example, we have in counter equal to 1 is initialization, counter less than or equal to 1 is condition or evaluation, counter equal to counter plus 1 is updating or iteration. About for statement. For statement also check the condition before entering the loop, and all the operation will be done in same sequence as while statement. Hence, we can see the flowchart is almost the same. Now, let's see an example of counter control questions, which is calculate the area of 10 rectangle. We may start with IPO, so the input will be length and width. Process will be repeat reading input and calculate area 10 times. Output will be area. As for the pseudocode, we will start with begin, counter equal to 1, while counter less than or equal to 10, input length, width, area equal to length times width, print area, Now, let's see the Java program of counter control that used while statement. As you can see there, I already highlighted in red color the difference between while statement and for statement. In while statement, they use in counter equal to 1. But in for statement, they use for in counter equal to 1, counter less than 10, and counter equal to counter plus 1. Now, let's move on to sentinel control. In sentinel control, the loop will stop when sentinel value is reached. Sentinel value is a special value to indicate the end of data entry, such as we can enter 0, -1, 999. Now, let's see an example of sentinel control questions. Calculate the total and average of marks entered by user until the user key in -1. The key point here is until user key in -1. So, by saying the question, we will get the key point. So, we will notice that this is a sentinel control questions. Okay. Now, let's see the pseudocode. As we can start with begin, mark, total, average, I equal to 0, enter mark, while mark exclamation equal to -1, total equal to total plus mark, I equal to I plus I1, enter mark, and while average equal to total over I, display total and average. Then we can end the pseudocode. Thank you.
I will be explaining the last learning outcomes for 3.3 use of control structures, which is explaining types of programming errors. There are 3 types of errors: syntax or compile time error, runtime error, and logic error. Firstly, we will be discussing about syntax error. Syntax error usually occurs when the syntax of the programming language is violated. Common examples would be misspelled variable and function names, missing semicolons. I think this is the most common mistakes that we do. Improperly matches parentheses, square brackets, and curly braces. Incorrect format in selection and loop statements. So when this happens, the statements cannot be translated and the program cannot be executed because the computer is unable to understand our program. Okay, so next we will be discussing about runtime error. Runtime error occurs when a program with no syntax error asks the computer to do something that the computer is unable to reliably do. Common examples would be trying to divide by a variable that contains a value of 0. Of course, we cannot divide zeros. And then trying to open a file that simply doesn't exist. And then the last error would be logic error. Logic error usually occurs when there is a design flaw in your program. It is very difficult to detect because it doesn't cause any runtime error and it does not display error messages. The only sign that we know there is an error in our program is because the output is incorrect from what we expected. Common examples would be multiplying when you should be dividing, adding when you should be subtracting, opening and using data from the wrong file, and displaying the wrong messages. However, logic error can be detected by testing the program thoroughly, comparing its output to manually calculated results. That's all from me.